Welcome to Lesson 9, where we shift from detection to response. Filters find the bad actor. Actions decide what actually happens next. Up to now, you've leaned on the default. Iptables drops the IP and that's it. But Fail2ban can stack actions. Ban the IP, email the admin, post to Slack, log to SysLog, even push to a community block list. We'll tour what ships in action.d, compare iptables, nftables, and ipset, stack multiple actions in one jail, and finally write our own from scratch. Start with the inventory. Look inside, ixruc fail2ban action.d, and you'll find roughly 30 .conf files, and they fall into 4 buckets. Firewall actions, iptables, nftables, UFW, route, are your default droppers. Lookup tables, the ipset variants, exist for when your ban list grows past a few thousand and chain traversal starts costing you. Notify actions wrap sendmail and SMTP for alerting. And webhook actions, abuse IPDB, Cloudflare, badips, push bans outward to community lists or your CDN. Run ls on that directory now. What ships varies slightly by distro. Open any one of those files and you'll see the same skeleton. An action is really just 4 shell hooks. Action start sets up the chain when the jail boots. Action ban fires on every ban. Action unban runs when bantime expires. And action stop tears the chain down. Look at iptables multiport here. Action ban is literally 1 iptables. I command with the offender's IP spliced in where you see angle bracket IP. Everything in angle brackets is a placeholder, and the init block at the bottom defines the defaults the jail can override. That iptables command isn't your only option. There are actually 3 backends Fail2ban can drive. Iptables is the universal default, fine until you start collecting bans. Every packet walks the chain linearly, so 1,000 bans means 1,000 lookups. nftables is the modern replacement. Default on Debian 11 and RL 8 and up, with faster set-based matching. And ipset sits on top of iptables with an 01 hash lookup. That's what you reach for when a recidive jail is holding 10,000 addresses without breaking a sweat. Now, picking a backend is only half the story. Actions don't have to work alone. The action directive accepts a list, stack them on consecutive indented lines, and every ban triggers all of them, in order sharing the same IP and jail name placeholders. So here, one SSHD ban inserts the iptables reject rule, fires off a Huawei's email to the admin, and posts to Slack. One catch: they run sequentially on the main thread, so a slow webhook will stall Fail2ban. Keep those async or use the buffered variants. Speaking of email, it's the most common second action, but naively sending 1 message per ban will flood your inbox the moment a botnet shows up. Fail2ban ships 3 patterns to handle that. Send mail, always fires on every ban with a always lookup attached, fine if you're seeing under 20 bans a day. SendMail buffered batches them into a digest every n minutes, which is what most production boxes actually want. And Mail always lines adds the matching log context for incident review. All 3 assume a working local SendMail or postfix. Test it with a plain mail command before you wire anything into a jail. Now, modern alerting usually means chat, and here Fail2ban leaves you on your own, because there's no Slack action in the box. The good news is, you don't need one. This whole file is just curl posting JSON to an incoming webhook with the standard placeholders, IP, name, failures, find time, ban time, interpolated into the message body. 2 details matter in production: the max time of 5 seconds, so a slow Slack endpoint can never stall your ban pipeline, and the trailing hybridity true, so a failed post never aborts the action. Leave action unban empty unless you genuinely want twice the noise, and swap the hook URL in jail, local. Same skeleton works for Discord, Mattermost, or any HTTP API. We just used several of these placeholders in that Slack snippet, so let's make the full set explicit. Fail2ban substitutes 8 values into your action commands before the shell ever sees them. IP, name, failures, find time, bantime, port, protocol, and matches, each pulled from either Fail2ban itself, jail.local, or the Actions Init section. The one habit worth burning in, always quote them inside JSON or HTTP bodies, because a malformed IP shouldn't be the thing that breaks your integration. Now, a performance reality check. Plain iptables multiport adds one rule per banned IP, and every incoming packet walks that entire chain. Fine at 50 bands, painful at 5,000. Switching the recidiv jail to iptables ipset proto6 moves those addresses into a kernel hash set, so lookup stays 01 no matter how big it grows. The numbers at the bottom say it plainly. 12% kernel CPU drops to under 1, flat. Past 1,000 bands, this isn't optional. Now let's stack everything into one working preset. The action block lists 3 things on the SSHD jail: iptables multiport for the immediate block, send mail buffered to batch admin alerts 20 bands at a time, and the Slack webhook from slide 7 for real-time chat notifications. The default section just feeds the email addresses and MTA into those placeholders. One warning worth taking seriously: pipe a test message through mail before you reload, because a broken send mail will quietly stall the whole action chain. That wraps stage 3. 6 skills you can put to work today. Sort the 30 shipped actions into firewall, lookup, notify, and webhook buckets and pick one from each. Read any action.conf knowing it's just start, ban, unban, stop. Choose iptables, nftables, or ipset based on scale. Stack actions with indented lines and timeouts. Quote your placeholders properly in JSON bodies, and when nothing fits, write your own with curl, max time, and a trailing true so a bad call never breaks the chain. Stage 4 picks up next with production operations. So that's stage 3 in the bag: regex foundation, custom filters, multi-action stacking, and your own action.d drop-ins. Stage 4 shifts the question from "is it configured right?" to "is it actually working?" Lesson 10 picks up with monitoring and metrics, Prometheus exporters, Grafana dashboards, and the alert hygiene that keeps ban storms out of your inbox. Detection and response are wired up. Next, we make them observable. See you in Lesson 10.